Hello everyone. So this is part of the topic given to us, which is the engineering knowledge and data mining. And I was tasked in our group to discuss the data mining part. So my objective in this video reporting are the following. So we have the data mining concepts. The first one is to understand the need for analysis of large, complex, information-rich data sets, then identify the goals and primary tasks of a data mining process, describe the roots of data mining technology, then recognize the iterative character of a data mining process and specify its basic steps, and then explain the influence of data quality on a data mining process, establish the relation between the data warehousing and data mining, and lastly discuss the concepts of big data. So we have here the introduction. So the entire process of applying a computer-based methodology, including the new techniques for discovering knowledge from data, is called the data mining. So this means that we have the ability to extract useful knowledge hidden in this data and to act on that knowledge is becoming increasingly important in today's competitive world. So that's why data mining is an iterative process within which progress is defined by discovery through either automatic or manual methods. So, data mining is very useful in a scenario which there are no predetermined concept about what will constitute an interesting outcome. So we have another definition for the data mining. It is the search for new valuable and non-trivial information in large volumes of data. Therefore, it is a cooperative effort between humans and a computer. So we have here the two primary goals of the data mining. We have the prediction and description. So what's the difference between these two? So prediction, it involves using some variables or fields in the data set to predict unknown or future values of other variables of interest. On the other hand, um, we have the description. It focuses on finding the patterns describing the data that can be interpreted by humans. So we can put data mining activities in two different categories of data mining. And the first one is predictive data mining, which produces the model of the system described with a given dataset, and the descriptive data mining, which produces new non-trivial information based on the available dataset. So on the predictive end, the goal of data mining is to produce a model expressed in an executable code which can be used to perform classification, prediction, estimation, or other similar tasks. And for the descriptive end of the spectrum, the goal is to gain an understanding of the analyzed system by uncovering patterns and relationships in large. We have here the primary data mining tasks. So actually there are six. Number one, we have classification. Discovery of a predictive learning function that classifies a data item into one of the several predefined classes. And we have regression, discovery of a predictive learning function which maps a data item to a real value prediction variable. And number three, we have clustering. It is a common descriptive task in which one seeks to identify a finite set of categories or clusters to describe the data. And we have summarization. It is an additional descriptive task that involves methods for finding a compact description for a set or subset of data. And then we have dependency modeling. It is finding a local model that describes significant dependencies between variables or between the values of a feature in a dataset or in a part of a dataset. And lastly, change and deviation detection is discovering the most significant changes in a dataset. So the success of a data mining engagement would really depend largely on the amount of energy, knowledge, and creativity that the designer puts into it. So in the essence, it's just like solving a puzzle. We have data mining roots. So what are the roots of data mining? Okay, so we have to consider these two disciplines in data mining. The first one is statistics, and the other one is the machine learning. So we have here the system identification top-down steps. So we have step one, we have the structure identification, and the other is parameter identification. So in this step, in the structure identification, what we need is to apply a prior knowledge about the target system to determine a class of models within which the search for the most suitable model is to be conducted. And in the second step, we have the parameter identification. In this step, when the structure of the model is known, all we need to do is to apply optimization techniques to determine the parameter vector t such that the resulting model, which is the y asterisk, equals the functions of a unit input vector and the parameter vector t. So here is the block diagram for parameter identification. So as you can see here in the block diagram, we have the u as our input unit vector, then we have the target system to be identified, and then we have y. Y here is the model's output. And we also have here the mathematical model. So again, y asterisk is what we call the optimization technique done out from y, from a simple y equals the functions of u comma t. So here you have asterisk, y asterisk equals to a function of unit vector and a parameter vector t. So if there were minimal errors occur here in the output, so the the parameterized equation y will be subtracted by this y asterisk, which is the optimization optimization technique, and once the result is already satisfactorily, then that's the time that you will now have a meaningful outcome. So let's move on to the data mining process. So we have data mining process is a process of discovering various models, summaries, and derived values from a given collection of data. So as you can see here, the figure 1.2, we have the data mining process steps. So the first step is state the problem. So the first step requires the combined expertise of an application domain and a data mining expert, and of course the application expert. And for the collection of data, or the second step, it is concerned with how data are generated and collected. And then we have the third step, which is the pre-process the data. So data pre-processing usually includes at least two common tasks, and these are the outlier detection and scaling, encoding, and selecting features. For outliers, so these are unusual data values that are not consistent with the most observations. So that's why outliers is also called as removal. And then for the other one, scaling, encoding, and selecting features. So data pre-processing includes several steps such as variable scaling and different types of encoding. For example, one feature with a range of 0 to 1 and the other is from negative 100 to 100, then definitely this will affect to the data mining results. And then we have the fourth step, which is the estimate the model. So this process is not straightforward. Usually, the implementation is based on several models, and selecting the best one is an additional task. And for the fifth step is interpret the models and draw conclusions. So in most cases, data mining model should help in decision making, since models need to be interpreted in order for it to become useful. We have here the conceptual model, which is what we call the CRISP-VM or CRISP-VM model. So this methodology provides a structured approach in planning a data mining project. So as you can see in the figure, so there are a sequence of events which starts with a business understanding, data preparation, modeling, evaluation, and deployment. And all of these events are very dependent on what we so called the data. We have from data collection to data preprocessing. So as an example is what we see in the figure. So the figure shows, or we can see a dramatic increase of internet hosts in recent years, where these numbers are directly proportional to the amount of data stored on the internet. So we have here another figures, figure 1.5. So it is a simplified graphical representation of a dataset and its characteristics. And for figure 1.6, so we can see that all independent variables are accepted as outputs from the system for which we are establishing a model. And independent variables are inputs to the system as being represented in this figure. And then there are a number of indicators of data quality that have to be taken care of in the preprocessing phase of a data mining process. So what are these? So we have the data should be accurate. The data should be stored according to data type. The data should have integrity. The data should be consistent. The data should not be redundant. The data should be timely. The data should be well understood. And the data set should be complete. Data warehouse for data mining. Although the existence of data warehouse is not a prerequisite of data mining in practice, the task of data mining, especially for some large companies, is made a lot easier by having access to a data warehouse. So what do we mean by data warehouse? So it is a collection of integrated subject-oriented databases designed to support the decision support functions or DSF, where each unit of data is relevant to some moment in time. So here are the categories of data in a warehouse data. Number one, you have old detailed data. Then you have the current or the new detailed data. Then you have lightly summarized data. Then highly summarized data. And metadata, which is the data directory. So there are four main types of transformations in data warehouse. So we have the simple transformations, cleansing and scrubbing, integration, and aggregation and summarization. So let's start with the simple transformations. Simple transformations are building blocks of all other more complex transformations. As an example, includes changing the data type of a field or replacing an encoded field value with a decoded value. Cleansing and scrubbing. This transformation ensures consistent formatting and usage of a field or of related groups of fields. And then integration. This is a process of taking operational data from one or more source and mapping it field by field onto a new data source structure in the data warehouse. And then lastly, we have the aggregation and summarization. So these are methods of condensing instances of data found in the operational environment into fewer instances in the warehouse. And then we have the three-stage data warehousing development process. So the first one is modeling. So in a simple terms, it is to take the time to understand business processes. Then we have building, is to establish requirements for tools that suits the types of decision support necessary for the targeted business process. And lastly, number 3 is deploying. Deploying is just simply to implement. Okay, so we have from big data to data science. So there are actually different types of data sources. This includes operational data, dark data, commercial data, social data, and public data. Operational data actually comes from the traditional transactional systems, where the assumption is that it includes monitoring streaming data coming from the large amount of sources. And dark data, so it is a large amount of data that you already own, but you do not use them in current decision processes. So it may include your emails, contracts, or written reports. And then for commercial data, it is available on the market and may be purchased from some large companies. And then you have social data. These are coming from Facebook, Twitter, and other general social medias. And then we have public. So this involves economic, social demographic, or weather data. And then we have big data. Simply means that not only a large volume of data, but also other features that differentiate it from the concepts of massive data and very large data. And then we have 4 dimensions, or the 4V model. We have number 1, volume. Number 2 is the variety, and then we have velocity and veracity. So when we say volume, this refers to the magnitude of the data. And for variety, this refers to the structural heterogeneity in a data set, including the use and benefits of various types of structured, semi-structured, and unstructured data. And then velocity, this refers to the rate at which data are generated and the speed at which it should be analyzed and acted upon. And then lastly, we have the veracity. Veracity highlights the unreliability inherent in some sources of today's digital. There are main problems with the implementations and threats to big data solutions. So these are data breaches and reduced security, intrusion of users' privacy, unfair use of data, escalating cost of data movement, scalability of computations, and data quality. And business aspect of data mining, why a data mining project fails. So a number of data mining projects have failed in the past years because one or more of these criteria were not met. So this includes there must be a well-defined problem, the data must be available, the data must be relevant, adequate, and clean. Then the problem should not be solvable by means of ordinary query or online analytical processing tools, which is OLAP tools only, and the results must be actionable. So I have here a figure 1.8 wherein it is effort in data mining process. So the percentage allotted in business objectives is 20% higher. For data preparation, that's above 50%. For data mining, we have above 10%, and consolidated results is only 10%. So this ends my video reporting. So thank you for listening.